So hello, my name is Carl Hugo Bellmark. I come from the company called OPAX. Before I begin my presentation, I want to make sure to point out that the OPAX company does one thing and one thing only. We only do video analysis system for outdoor perimeter protection. So we make system to protect your perimeter. Now, what is the difference between OPAX video content analysis and other video content analysis products? I assume that you know what video content analysis is. I will just give a short explanation what we are using it for. We are analyzing the video that comes from the surveillance cameras, and based on rules of what is going on in the field of view of the camera, we create alarms. The basic of video content analysis. Now, the OPAX system is made by the Norwegian Army. When the Norwegian Army started to develop this system, they said it must be able to do two things very well. Number one, it must be able to classify the object it sees very well. This means I must be sure if it's a human, a bear, or a truck. And I must do this very well and scientifically. I cannot guess. That was number one. Number two, that is that the system must be fast to set up. There is no time in military operations to wait for someone to learn something. You come out into the field, you must be running instantly. So how do we do this? Now we come to the difference between OPAX and most other systems in the market. Now, because the Norwegian Army was looking for a way how to scientifically say what the camera was looking at, they started using differential GPS calibration. So how do we do this? The first thing we do is to tell the system where in the world the camera is. So now we know where the camera is, and we do that by using something called the UTM measurement system. This tells you like longitude and latitude, but also the height over the sea. So we have northing and easting and height above the sea. Now, this gives us on the millimeter the exact position of the camera. Number one. Number two is to explain what the camera is looking at. What we do then is this. We use GPS information to plot the area that the camera is looking at. Today, there are several ways to get this information. You can have a GPS, or you can take it from Google Earth, for example, or there are other sources. Now, if we use a GPS, we have a differential GPS, we go out in the field of the view of the camera and we plot the entire area. We take a USB stick, we put it into the GPS, we extract the text file, and we put that text file into the computer. And we're up and running. So we do two things and two things only to get the system up and running. Therefore, you are up and running within a matter of 1 hour. This is a big difference, and it's all based on scientific information. When you have done this, when you have told the system where the camera is and what the world looks like by GPS positions, there is nothing else you can change. You cannot tweak any information. This is the only thing you can do. Because this was what the Norwegian Army demanded. It had to be very, very accurate and exact. The effect of this is suddenly we have what we call a virtual understanding of where the objects are moving. Because we know where the camera is, and we can tell that the object that is moving is 35 meters away from the camera, because we know the GPS position of the camera and we know the GPS position of the object moving. That's number one. Number two, we see how many pixels are moving. If it's 12 pixels on the height and 4 pixels on the width, 35 meters away, we probably have a human. Then of course there are certain other aspects of this I cannot tell you about, but which makes the classification extremely accurate. This is very important to avoid false alarms. So, how do we avoid false alarms? Just to give you an idea, if a bird flies by your camera, it can easily be mistaken for a human or for a car. But because OPAX, we measure the speed, because we're able to tell how fast the object is moving between the different GPS positions, we can say anything that moves faster than 10 meters per second, no alarm. And there's only Ben Johnson who runs 10 meters per second. So therefore, we are able, for example, in OPAX, to say that if you have a car, because we know how big a car is, if you have a car that drives faster than 30 km per hour, you would have an alarm. So this is fantastic, for example, for power plants. Another thing, because we have the GPS information of each moving object, we are able to plot this movement on a graphical overview map. So imagine that your cameras are seeing your entire perimeter and you have a satellite image of your perimeter and suddenly can see all the movements of humans and cars plotted on the map. You get full control.